All right, this is our third of three transformations, multiple transformations going on at once in this equation. And so what I'm going to do is I'm going to start with, like we've done on the other two videos, I'm going to start with the parent function. So the parent function on this one is going to be, if you notice, it's x squared. So y equals x squared. I'm going to make a table just like we did on the other ones. We'll do an xy table. We'll do -2, -1, 0, 1, and 2. And I choose those numbers because that's where the center of this parabola is going to be. So -2 squared, or the vertex of the parabola. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. And 2 squared is 4. So our parabola is going to be -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And then it's also going to be over 3 up 9, and back 3 up 9. So we can connect these dots in a nice curve. That's going to be our parabola, like so. All right, so there's our beautiful parent function over in pink on the graph. And so now, what I said in the second example is let's try doing this one without making a table. And so I'm going to take this new function, this offspring function, and I'm going to try graphing that without, like I said, without making an XY table. And then we could, come over the table after that. And we can talk about how could you make a table without having to actually plug it into the equation as well. So, but first, one thing I need to remind you of is you notice how there's this 1/2 in front of x? And that's not outside of the parentheses. And so what we're going to do is we're going to factor that out. So we're going to factor out a 1/2, and then we'll have x plus something squared minus 3. So this is like undistributing. That's what we call factoring. So we need to think 1/2 times what will give me 4? Well, 1/2 of 8 will give me 4. And so what we're doing is we're just rewriting that function, but we're pulling that 1/2 out. We have to do that whenever we're going to do this graphing, because that's going to tell us how far it's shifting left and right. And so this tells me it's going to be to the left 8. It's going to be down 3. So let's do that right now. Left 8, 1, 2, 3, 4, 5, 6, 7, 8. Down 3. So there's going to be our new vertex. It's going to be right there. Okay. And then we also have this 1/2, which is going to be a horizontal stretch by 2. It's always the reciprocal of that fraction. So if there was a 2 inside there, would be a horizontal compression by 1/2. And so what that means we're doing is we're pulling it out. We're pulling that graph horizontally by 2. And I'll talk about how we're going to do that. And then the negative also means it's going to be upside down, or reflection over the x-axis. Basically, it's just going to be an upside down parabola. So how are we going to graph this? Well, if you notice on the pink graph, to go from the vertex to that first point, we go over 1, up 2. Well, do you remember how I said it's going to stretch it twice as wide horizontally? So this time we're going to go over 2 and then down 1 since it's upside down. Over 2, down 1 since it's upside down. And then we're going to keep doing that pattern. Notice how we go over 2, up 4 to get to that next point on this parabola. So instead of going over 2, down 4, we're going to stretch that twice as wide. So we're going to go over 4, down 4. It's going to be right there. Of course, this one's off the graph, so I'll kind of estimate it. Over 4, down 4. So we're right about there, maybe. And so this parabola is going to look something like that. You see how I did that without having to make a table? And then you could make a table from there. We've got -8 and -3. we've got -6, -4, and -4, then 1, 2, 3, 4, 5, 6, 7, -4, -7, and then we could do these points over here, so -10, -4. So how do we do this table? If we wanted to make a table without having to graph it, how would we do that? Well, this 0, 0, this one corresponds with the new vertex, and that is -8, -3. And so that was because it moved to the left 8, and down 3. So what you could do for your new origin, and actually let me erase this table, I want to start fresh, is we could make that kind of our center point. X, Y, and then we'll do -8, -3. And that's going to be kind of like our 0, 0, because it moved left 8, down 3. Well, and then the negative flips it upside down, and the 1/2 is going to stretch it horizontally. So that's affecting the X values. So instead of moving over 1, like we do on this table where we go +1, instead of going +1, we're going to go +2, because it's stretching it out horizontally by a factor of 2. And so then the next point is, instead of going +1, we're going to go +2 from there, so it'd be -4. I didn't do the best job of mapping this out. And then same thing going the other way. Instead of going -1 to -1, we're going to go -2 to -10 and -12. Okay, then how do we get our Y values? Well, we go, instead of going up 1 to get here, this is going to go upside down, and so it's going to go down 1 to get the next few points, because it's upside down, so it'd be -4 on both sides of that. Remember, the parabolas are symmetric, so each point's going to kind of be symmetric. And then instead of going up 4 from the origin, we're going to go down 4. So down 4 to get there, so it'd be -7 and -7, and that's exactly what we see on our graph here at those 2 points. So you could come up with a table by just using all of these transformation rules, or you could just graph it by using all the transformation rules, or if you liked in the first 2 videos to just make the table by finding that 0 point inside the function, that also works. Any of those methods are great methods to graphing these.